Alright, good morning. This video is both for Brodie in group 3. So Brodie, your day is Thursday, May 8th. Group 3, your day would be Tuesday, May 6th. No reason to make two different videos. Don't have any time for it anyway. It's 12:30. So we will be going over fraction of a whole number. Oh, let me set my timer real quick. Fraction of a whole number. And then we also have making mixed numbers, making improper fractions. So let's get to it because these videos are kind of long that we'll be watching.
Buddy, instructor Beats back again here with another fraction lesson. Today we're going to be looking at whole numbers as fractions. So let's build it up and look at our objective today. Today we will be able to understand that whole numbers can be written as fractions and recognize those patterns by using unit fractions. So we have a whole video on unit fractions if you need a lesson on it, right? But here's a quick overview, all right? A unit fraction is one equal part of the whole. If I have one whole and split it into 4 equal parts, I have made fourths, right? Each of those pieces now has a value of 1/4. 1/4 is my unit fraction. It is the building block of my whole. To make the whole, I would need 4 1/4, right? So that concept can be used later in our video, but let's review some math vocabulary, right? So here we have a fraction, and we know that the top part of a fraction is called the numerator, and the bottom part of our fraction is called the denominator, okay? The denominator is how many pieces one whole is split into, okay? That's going to be a very important concept as well today. And our numerator tells us the number of unit fractions that make up our fraction, okay? And again, we have another lesson on that, but this is just a little bit of a review because we'll be using these terms in our lesson today. Let's tell an instructive story to help us understand what we're talking about today, okay? It's your birthday today, and you order one whole pizza, right? But of course, you're not going to eat the whole pizza by yourself, so you split it into 8 equal pieces. You can see those right here. 1, 2, 3, 4, 5, 6, 7, 8. I've already cut those for you. It's only fair that they're equal pieces, right? Because we want to share equally. So your unit fraction, right, each of these pieces is going to be worth 1/8. So our unit fraction in this story is 1/8 because that's how much each of these pieces is worth, right? I split it into 8 pieces, which means one of them would be 1 out of 8, okay? Now, this is not a trick question. How many slices would you need to make one whole pizza, right? Well, you would need 8. So if the whole cake is eaten, you could say you ate 1 whole, right? Or you could say you ate 8 out of 8. And of course, after dinner, you want to eat a cookie, right? But for this one, you're not going to split it with 8 people. You're only going to split it equally with 3. And again, we have to share it equally. So I'm going to do my best to split this cookie up as equally as possible into 3 equal pieces, right? Which means my unit fraction would be 1 out of 3 because each of these pieces would be worth 1/3. So if I wanted to build one whole cookie again, I would need 3 1/3. So if I put 3 1/3 together, as you can see, that equals 1 whole, or that would be 3 out of 3, right? My denominator is 3, so it's split into 3 total pieces, and I needed 3 unit fractions, which is what my numerator tells me, to make one whole cookie. So after dinner, you're going to do some crafts. So you have this string right here, and you need to cut it into 6 equal pieces for whatever craft you're doing. I don't know, I don't do crafts with strings, but I'm sure that'd be fun. Okay, so I'm going to split this into 6 equal pieces, all right? And each of these, of course, would be worth 1 out of 6. Our unit fraction is 1/6. Our denominator is 6 because we split it into 6 equal pieces, and each of those pieces is worth 1/6. So if if I wanted to put it back together to make one whole rope, right, I could say I had one whole rope, or I could say that I had 6, 6, because my denominator is 6, right? I had 6 equal pieces, and my numerator needs to be 6 because I need 6 unit fractions to build that one whole. So we could say one whole, or, I forgot my or right here, 6, 6. Now let's just take this one step further. Let's say, for some reason, you wanted to take your napkin from dinner, you wanted to pull a prank on your brother, so you split that napkin into 100 pieces for him to pick up. I don't know why you do that, but let's say you did, right? So again, I'm not going to write all the unit fractions out because there's 100 of them, but here's my one whole, right? And I split it into 100 equal pieces. How many pieces would your brother have to pick up the whole napkin? And of course that would be 100 over 100, right? Your denominator tells you how many equal pieces you split your whole into, and he would need to pick up 100 unit fractions to pick up the whole thing. So we could say that this right here is one whole, or 100, 100. What do you recognize about all the fractions that we said were equal to one whole? Hopefully you're seeing a pattern right here, right? Which leads us to our first pattern we want to recognize. When the numerator is the same as the denominator, the fraction is equal to one whole. So if your one whole pizza is split into 8 equal pieces, you would need 8 of them to say you ate one whole pizza, right? It's not tricky, but sometimes we don't think about it like that. So here we have a bunch of fractions. These are typically the fractions that we'll be using in our lessons, that the numerator is the same as the denominator, right? So 2 halves, I'm not going to do this for all of them, but let's say you had a whole circle and you split it into 2, right? You would need 2 unit fractions to make the whole, right? So what I do is I draw a 1 around this. Now, I don't draw a really good one because I don't want to spend a lot of time on it. It kind of looks like a rectangle, but pretend like that's a 1 because we call these fractions big 1. It's kind of like when you dress up for a costume party, right? Let's say you dressed up as a vampire. Well, you're not really a vampire, you're really yourself. Well, the whole number 1 has dressed up like some fractions, right? And even though they look different, they all have the same value of one whole. If you split a brownie into 6 pieces and ate 6 of them, you ate one whole brownie. If you took that same brownie and split it into 8 pieces, because you had to share it with more people, and you ate 8 of them, you still ate one whole brownie. So I draw this little 1 around it to kind of remind myself and to remind my students that these fractions, although they are written as fractions, are all equivalent to 1. And we call it the big 1. So what if we had other whole numbers, right? Not just 1, okay? So here we have 3 pizzas. I don't know why you want to eat them. There's nothing on them. It's just a plain circle. But here we have 3 pizzas, right? And we want to split each of them into 3 pieces. And again, I'm going to do my best. Thirds are kind of hard for me to be as equal as possible. If I'm a little off, let's just pretend like we shared these pizzas equally. We partitioned them into 3 equal pieces. There we go. And let's say I wanted one whole pizza. So we just learned that if we split our one whole pizza into 3 pieces, right, each of these would be worth 1/3. And of course, if you ate all 3 pizzas, that would be one whole or 3/3, right? This is a big 1. So there's my 1, okay, around my 3/3. Now, here's a misconception. This is what we need to remind ourselves about what a denominator means. Here you see 9 pieces, but the denominator tells us how many total pieces one whole is split into. So this whole pizza is also split into thirds, which means each of these pieces are going to have a value of 1/3, okay? And to make one whole pizza, right, that would be 3/3 or a big 1. And here we have 1/3 again for each of these. It's my unit fraction, okay? So I'm going to put another big 1 here, which would be 3/3. Now, we know 1 is equal to 3/3. What if I ate 2 whole pizzas together, right? Well, if each one is made up of 3/3, if I had 2 pizzas, that would mean I ate 6/3. And that goes back to what our definition of a numerator is. The numerator tells us the number of unit fractions needed to build the fraction we're talking about. So if I wanted 2/3, I would need 1, 2, 3, denominator would still be 3 because each whole is split into 3 equal pieces. Well, what if you wanted to have 3 whole pizzas, right? Well, if you had 3 whole pizzas, that would be 9/3 because you'd still have 1, 2, 3, 4, 5, 6, 7, 8, 9 unit fractions that make up the fraction we're trying to build, which was 3 wholes. So if we want to write 3 wholes as a fraction, it would have to be 9/3. So I'm going to go ahead and write down 1 real quick, not as a big one, but just as a fraction, because I want you to see the pattern. Each whole that we just added another 3 unit fractions, right? So if your unit fraction is 1/3, 1 whole would be 3/3, 2 wholes would be 6/3, 3 wholes would be 9/3, right? So we're just skip counting by 3 is the pattern. So if you had 4 wholes, that would be 12/3, because you need another 3 unit fraction to build the next whole. So 9/3 plus another 3 unit fractions would be 12/3. If you wanted to make 5 wholes, that would be 15/3. You need 15 unit fractions to make 5 whole pizzas. So you can see the pattern of skip counting to see what fractions are equivalent to other wholes. So using that pattern, let's take a look at this we do, okay? So you should be jotting this down in your notes with me as we go. It says 18/6 is equal to how many wholes? Well, the first thing I need to recognize is my unit fraction, right? So if my denominator is 6, my unit fraction would be 1/6, okay? So I'm going to go ahead.
So make sure you have a dry erase board and dry erase marker out and writing down what he's writing down.
And just draw a hole. I'll do a rectangular hole right here, okay? I'm going to split it into 6 equal pieces. And again, it's not going to be perfect, okay? But if I'm a little off, just pretend like we just partitioned it into equal parts. So my unit fraction obviously would be 1/6. So 1 whole, right, would be equal to 6/6, which is a big one, right? Your numerator is the same as your denominator, okay? So if we use the pattern we just talked about, 2 wholes should be equal to 12/6 because I would need another 6 unit fractions to make another whole. 3 wholes would have to be equal to 18/6 because again I'd have to add another 6 unit fractions for my next whole. So I think 8/6 is equal to 3 wholes. But let's go ahead and draw it out and see if we're right using our area model. So here's another hole, and again our holes should be the same size, so I'm going to do my best. Okay, let's split this into 6 equal parts. I'm going to label each of them 1/6. So you can see right here I have 12 unit fractions, which made up 2 wholes, so 12/6 is correct. I draw my next hole right here, there we go, and label my unit fractions. Each piece is worth 1/6. And here you can see I have 3 holes. How many unit fractions did I need to build those 3 holes? I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's why my numerator is 18, because it tells you how many unit fractions you need to build the fraction you're talking about. And some of you, again, might be confused why the denominator is only 6 when you see 18 total pieces. You always have to remember that the denominator tells you how many total pieces 1 whole is split into. So this 1 whole is split into 6 pieces, this 1 whole is split into 6 pieces, and this 1 whole is split into 6 pieces. So that's why my denominator stays 6. My unit fraction was 1/6, that's my building block, and I needed 18 of those to build 3 wholes. So you can use the pattern, or you could draw an area model to help you. Alright, so here's our you try problem. The question says how many 8s would you need to make 4 whole brownies, okay? So you can either draw out 4 whole brownies and split it into the unit fractions and then count them, or you could use your unit fraction and recognize the patterns that we were talking about the last couple problems to try to solve it that way. Either way you do it is fine as long as you try, right? It's okay to fail as long as you learn from it. So go ahead and pause the video, try it, and then push play to check your work. So hopefully you just paused it, and now we're checking it out. So first of all, I know my unit fraction is going to be 1/8, right? We said 8. So each whole brownie that I draw, I'm going to need to split into 8 pieces. And again, a little bit messy, right? But I know each of these pieces is worth 1/8, right? So I'm not going to go ahead and draw them all out, because that would take me forever. I'm just going to label a couple of them so you can kind of see. So first of all, you know your denominator is going to be 8, because that's how many each whole is split into. So what is the number of unit fractions you needed to build 4 whole brownies? So you have 8 here, plus another 8, that's 16, plus another 8, that's 24, plus another 8, that would be 32 eighths is equal to 4 wholes. Okay, if you didn't draw it out and you just used your pattern, you know that 1/8 was your unit fraction, right? Which means 1 whole would be equal to 8 eighths, which we call a big 1. You draw a 1 around it to kind of help you remember that. So now I know I'm just going to be skip counting by 8. So 2 wholes would be 16 eighths, 3 wholes would be 24 eighths, and then 4 wholes would have been another 8 unit fractions were needed. So that would have been 32 eighths. Either way you did it is fine, and this leads us to our key thought, right? Which is whole numbers can also be written as fractions by using our unit fraction knowledge. Thank you so much for checking us out today. We really appreciate you spending your time.
Alright, so this video is going to help you actually much later with an assignment that we're going to do toward the end of learning all about these fractions. Okay? So get your notebook out, and we're on the fraction of a whole number page. So group 3, this is 5, 6, 25, and for Brodie, this is 5, 8, 25. Alright, let's read. Fraction of a whole number. Under each flap, draw a picture to show the answer. I forgot to mention at the beginning of the video, you should have done your probes. If you did not do your probes or math multiplication fluency, you'll have to wait until the end if you have time. Also update the board, update your B, take flashcards if you need it. Alright. So 1/4 of 12. Under each flap, draw a picture to show the answer. Well, you need 12 of something, and you're dividing it by 4/4. So if I did circles, 1, 2, 3, 4 going across, 5, 6, 7, 8. 9, 10, 11, 12. Well, now I'm at 12. And if it's divided by fourths, there's 1, 2, 3, 4 pieces, right? So 1/4 of 12 equals, this is the 1, so 1, 2, 3. Now I'm going to show you another way that you need to know, because this is the picture way, but I'm going to show you the mathematical way that you'll need to know. So whenever you see something like this, if you go in this order and you divide these two numbers, 12 divided by 4, and then you multiply whatever that answer is by the numerator, you will get the answer. So 12 divided by 4 equals 3. 3 times 1 equals 3. So write that down. Make sure you're working quickly. Lots to cover. So you can even do another little note here. Divide. Whatever you get from that answer, you multiply. I haven't done this in a while, so I hope that's still the way it's done. I haven't used it in a while. We'll find out when we do this one. 2/3 of 9. So you're dividing 9 up into thirds. So you can use circles or squares. So there's 1 square, 2 square, 3. And I'm stopping there because I'm dividing by 3. Just like up here, I did 4 going across. That's what we're dividing it by. So 3, 4, 5, 6, 7, 8, and 9. And I'm dividing it into thirds. So there's 1/3, 2/3, 3/3 right there. And I need to shade 2 of those thirds. So this is 1/3 that I'm shading. This is 2/3 that I'm shading. So how many are shaded? 1, 2, 3, 4, 5, 6. So 2/3 of 9 equals 6. Now mathematically, you get 9 divided by 3, and that answer is multiplied by 2. So 9 divided by 3 equals 3. 3 times 2 equals 6. So make sure you write that down. Most teachers will teach you this part, but they won't show you visually. Or they have, but you've forgotten. So 9 is divided by 3, and whatever that answer is multiplied by 2. Okay. Pause the video if you need more time. And write quickly, but legible. 2/6 of 18. So 18, and it's being divided into 6. So 1, 2, 3, 4, 5, 6. Circles are just easier to do. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And let's see. So divide your circles by 6. So 1, 2, 3, 4, 5, 6. There's our 6. And we need to shade 2 of those 6. It's not 2 circles, it's 2 6. Not just the 2. I don't want you to be confused by that. It's not 2 circles, it's 2 6. And within those 2 6 is 1, 2, 3, 4, 5, 6. So 2 6 of 18 equals 6. And the mathematical way is 2 over 6 and 18. So take 18 and divide by 6, you get 3. And then you take that answer and you multiply by 2. So 3 times 2 is 6. That's a division symbol. Sorry, it's sloppy. So that is the mathematical way that you solve for that. If you didn't have enough time, go back, pause the video. Now the next two videos are all about improper fractions and mixed numbers. So let's get going on that.
Fractions. First, let's quickly recap what we know about fractions. In a fraction, the number at the top is called the numerator. It refers to the number of parts you have out of a whole. The number at the bottom is called the denominator. It refers to the total number of equal parts there are of a whole. The line in between the numerator and the denominator is called a vinculum. This fraction shown here, 3/4, is an example of a proper fraction. A proper fraction is when the numerator is less than the denominator. Proper fractions represent a value that is less than 1. What does that mean exactly? Let's use visuals to help us better understand this concept. If you ate 3/4 of a pizza, that means you ate 3 slices out of 4 in total. And as you can see from the picture, that means you did not eat one whole pizza, which shows that the proper fraction 3/4 is a value that is less than 1. Let's explore this with one more proper fraction. This fraction, 2/5, is a proper fraction because, as we know, proper fractions have a numerator that is less than the denominator. If we apply 2/5 to a real-life example, we could say that you ate 2 slices of cake out of a total of 5 slices. This is what it would look like as a visual representation. So you can see with this new example of a different proper fraction, it still shows a value that is less than 1. Now that we understand proper fractions, let's move on to improper fractions. This fraction here, 5/4 or 5/4, is an example of an improper fraction. What do you notice? Improper fractions have a numerator that is either equal to or greater than the denominator. Improper fractions represent a value that is greater than 1. Let's apply this to our pizza scenario so you can visualize it to have a better understanding. Let's break this improper fraction down. The numerator, 5, means that you ate 5 slices of pizza. The denominator, 4, means that the pizzas were cut into quarters. This means that you ate 5/4. From this representation, you can clearly see that the improper fraction 5/4 has a value that is greater than 1 because you ate more than one whole pizza. Let's have a look at another improper fraction. Here is the improper fraction 7/3. We are going to use a rectangle to show a visual representation of what 7/3 looks like. If we break it down, the denominator, 3, means that our whole rectangle was divided into thirds, giving us 3 equal parts. So each of these equal parts represents 1/3 of the rectangle. The numerator, 7, tells us that we have 7/3. Right now in the picture, we only have 3/3. So let's add 4 more thirds to make 7/3. Now that we have 7/3 showing, you can see that this improper fraction has indeed a value that is greater than 1, because we have more than one whole rectangle. We actually have 2 whole rectangles and an extra third. Let's recap what we learned today. For proper fractions, the numerator is less than the denominator. Proper fractions have a value that is less than 1.
So go ahead and write that down. You can use a sticky note to do that. I'll try to remember to put some in your notebooks. So proper fractions, numerator is less than denominator. And they have a value that is less than 1.
In improper fractions, the numerator is larger than the denominator. Improper fractions
Write that down. Improper fractions numerator is larger than the denominator. And they have a value greater than 1.
have a value that is greater than 1.
Thanks for watching. Please
let's see if we can get the next video in.
The content in that video will help you understand the content in this one better. First, let's quickly recap what we know about improper fractions. The new width was divided into halves because
I'm going to skip
now you
these.
can donuts. These donuts. How many donuts are there all together though? Well, here you can see that we have 2 whole donuts, and here is half of a donut. So altogether we have 2.5 donuts. This number right here that we just created is what we call a mixed number. A mixed number is a combination of a whole number and a fraction. Also, from this example, you can see that 5 halves is the same as 2.5. Let's explore improper fractions and mixed numbers further with another example. Let's look at the fraction 4/3. We know that this is definitely an improper fraction because the numerator is greater than the denominator. The numerator 4 tells me that I have 4 equal parts of something, and the denominator 3 tells me that the whole was divided into 3 equal parts. Here is what it would look like as a visual representation. You can see that there are 4 equal parts and that the whole was divided into thirds. So how can we represent this as a mixed number? Well, we can see that we have 1 whole circle and we have 1/3 of a circle. So the mixed number is 1 and 1/3. We're going to do one more example together before you get a chance to draw visual representations and convert improper fractions into mixed numbers yourself. Here is the improper fraction 7/4. If we break it down, the numerator 7 tells us that we have 7 equal parts of something. The denominator 4 tells us that the whole was divided into quarters. Instead of using a circle, we will use a square as a whole this time. It does not matter what picture or shape you use as long as you have the right amount of equal parts needed. This is what 7/4 looks like. To write 7/4 as a mixed number, we write down that we have 1 whole square and 3/4 of a square. So 7/4 is the same as 1 3/4. It is now your turn to put what you have learned into practice. For each of the improper fractions on the screen, create a visual representation. Remember, it does not matter what shape you use as long as you have the right amount of equal parts needed. Then, use your drawings to write the mixed numbers. There will be a 1-minute timer so the answers are not revealed before you are ready. It may be a good idea to pause the video to give yourself more time to complete the task. Good luck!
Go ahead and do that on your dry erase board and marker. Use your marker. Let's see if you got the answers right.
Thanks for watching. Please remember to subscribe.
All right. Alright, so there's my notes about proper fractions and improper fractions. Brodie, I already put your sticky notes on your book. Big kids, I'll do that in just a moment. So these 2 pages are homework. Making mixed numbers, making improper fractions. And I will tell you a shortcut on these. So if you multiply these 2 numbers and then add that answer to the numerator, then you will get an improper fraction. Remember, the denominator stays in your fraction, so it will still be over 4, but the numerator will be bigger because it's called improper. So multiply the denominator by the whole number, add the numerator. So here's the steps. Multiply denominator by whole number, then add the numerator. Alright, so homework, these 2 pages. Making mixed numbers and making improper fractions. Don't forget your cursive pages as well. Alright, y'all have a good day. See you when I get back.